Okay, so imagine this. You are sitting at your computer, you have a 10-minute long video in front of you, and you need to blur out every single car in that video. With traditional editing software, you would be clicking frame by frame, manually selecting each car thousands of times. It would take you hours, maybe even days. But what if I told you that Meta just dropped an AI called SAM3 that can do this in literally seconds? You just type car and boom, every single car in your entire video gets automatically detected and segmented. And I'm not talking about science fiction here. This is available right now today. Let me show you what I mean. Watch this. I'm going to type yellow school bus in SAM3 and look at this. Every single yellow school bus in this entire video across thousands of frames gets highlighted instantly. It found them all. It understood what a yellow school bus is, what makes it different from other vehicles, and it tracked every single one automatically. This isn't just an incremental update to some existing tool. This is a complete paradigm shift in how artificial intelligence sees and understands our world. Now, before we dive deep into this, I need to tell you something important. This video is going to be long because I'm going to cover everything about SAM3 in detail. I have put timestamps in the description, so if you want to jump to a specific section, you can do that. But here is the thing. If you genuinely want to learn about this technology, understand how it works, and actually be able to use it, then you need to watch this properly. If you are just here for quick surface level overview and you are not really interested in learning, you can leave right now. No hard feelings. But if you stay, I promise you by the end of this video, you will understand SAM3 better than 99% of people out there. And you will know exactly how to use it for your own project. Alright, before we get into the technical stuff, let me give you some context because understanding where SAM3 comes from will help you appreciate just how revolutionary this really is. Meta has been building the Segment Anything model series for a while now, and each version has been a massive leap forward. Back in April 2023, they released SAM1, and at the time, it was mind-blowing. You could click on anything in an image, literally anything, like a dog, a person, a building, whatever, and SAM1 would perfectly outline it. That was revolutionary because before that, AI struggled to segment objects it hadn't specifically been trained to recognize. Then in July 2024, they dropped SAM2, and that extended everything to video. Now you could click on an object in frame 1 and SAM2 would track it automatically throughout the entire video, even if it moved around, even if it went behind something and come back. That was huge for video editors. But here's the thing. With both SAM1 and SAM2, you still had to manually click on stuff. If you had 100 objects to segment, you needed to click 100 times. It was better than before, sure, but it was still manual labor. Now enter SAM3, released on November 19, 2025. This is where everything changes. With SAM3, you don't click on anything. You just describe what you want in plain English. You type person wearing a red shirt, and SAM3 finds every single person wearing a red shirt in your entire video. Not just one person, all of them automatically. Do you see the difference? This is the shift from you telling the AI where to look and the AI actually understanding what you are talking about and finding it on its own. Let me put this in perspective with a real example. Imagine you are editing a 10-minute video and you want to add a cool effect to all the cars in the video. With the old way, using SAM1 or 2, you would have to scrub through the video, click on every single car, every time a new one appears. At 30 frames per second, that's 18,000 frames you are dealing with. Even if you're first and then mark a car every 5 seconds, you are looking at hours of work. With SAM3, you type car once, done. 30 seconds later, every car across all 18,000 frames is detected, segmented, and ready for your effect. That's not just faster, that's a completely different way of working. And this is what I mean when I say paradigm shift. The tool isn't just better, it thinks differently. So now let's talk about what's actually happening under the hood here. What makes SAM3 so different? The answer is something called Promptable Concept Segmentation or PCS. Now I know that sounds like technical jargon, so let me break it down in a way that actually makes sense. There are three words there: Promptable, Concept, and Segmentation. Let's understand each one. So segmentation is the easy part. That just means drawing precise boundaries around objects in an image or video. Think of it like cutting out shapes from paper, but digitally and pixel perfect. That's what all the SAM models do. Promptable means you can give it instructions or prompts. You can tell it what to do using text or by clicking points or drawing boxes. That's your interface with the AI. But here's the magic word: concept. This is what's new and this is what changes everything. A concept isn't just a visual pattern, it's an idea that the AI actually understands. When you say yellow school bus, SAM3 doesn't just look for yellow rectangular shapes. It understands that a school bus is a specific type of vehicle. It knows that it's usually yellow. It has a certain shape. It often has a writing on the side. It has black stripes. And it's better than a car. It understands the concept of what a school bus is. That's completely different from just pattern matching. Let me give you another example to really drive this home. If you type dog wearing sunglasses, SAM3 has to understand multiple concepts here. It needs to know what a dog is, what sunglasses are, and what it means for a dog to be wearing sunglasses. That's not just finding pixels that look a certain way, that's understanding relationships between objects and context. That's closer to how humans see the world than anything we have had before. Now here are the numbers, and these numbers are honestly insane. SAM3 was trained on 270,000 unique concepts. Let me say that again. 270,000 different concepts. That's 50 times more than any previous benchmark in this field. And when they tested it against human performance on complex segmentation tasks, SAM3 achieved 75 to 80% on human level accuracy. Think about what that means. And AI is getting 3/4 of the way to matching human understanding of visual concepts. And when they compared SAM3 to its competitors, the results weren't even close. They tested it against Google's Gemini 2.5 Pro, which is one of the most advanced AI models in the world. On the same benchmark, Gemini scored 13% accuracy. SAM3 scored 54%. That's not twice as good. That's more than 4 times better. They tested it against OWLV2, which is a specialist model specifically designed for object detection. OWLV2 got 24%. SAM3 got 54%. It's beating specialist models at their own game. And the speed? Oh man, the speed is what really gets me. SAM3 can process a single image with more than 100 detected objects in 30 milliseconds. That's 0.03 seconds. That's faster than you can blink. For a full video at 30 frames per second, it can process in real time or faster. Compare that to traditional video editing, where you might spend 3 hours doing manual masking on a 5-minute video. SAM3 does it in under a minute. That's not an exaggeration, that's the actual performance. Alright, now you might be wondering, how did Meta build something this powerful? What's the secret? And this is where it really gets fascinating, because the story of how they trained SAM3 is almost as impressive as the model itself. The answer comes down to 2 things: an absolutely massive dataset and a really clever training process. Let me start with the dataset, because the numbers here are just staggering. Meta created something called the SACO dataset, which stands for Segment Anything with Concepts. This dataset contains 5.2 million images, 52,000 videos, and get this, 4 million unique non-phrases describing different concepts. And all of this is annotated with 1.4 billion masks. Billion with a B. To put that in perspective, that's the largest concept segmentation dataset ever created by a massive margin. Nothing else even comes close. Now you might be thinking, okay, that sounds expensive. How do you annotate 1.4 billion masks? If you paid humans to do that at even $1 per mask, you are looking at $1.4 billion. Obviously, that's not feasible. So Meta came up with a really smart solution. They built what they call a human and model in the loop data engine. Let me explain how this works, because it's actually brilliant. First, they use AI annotators, which are llama-based models, to look at images and propose diverse concepts that could be labeled. So the AI looks at a street scene and suggests things like red car, pedestrian crossing, traffic light showing green, building with glass windows, stuff like that. The AI has generated the ideas for what to label. Then they have AI verifiers, which are fine-tuned versions of Llama 3.2 that automatically check the quality of those annotators. The AI verifier looks at the mask and says, yeah, this mask correctly captures the red car. Or no, this mask is sloppy and includes part of the sidewalk. Reject it. Only when the AI systems hit a tricky edge case that they are not confident about, only then do human experts step in to make the final call. The result of this system is that they achieved twice the annotation throughput compared to traditional methods. Instead of humans doing every single annotation, the humans are acting more like quality control managers while the AI does the heavy lifting. It's like having 1,000 assistants doing the boring repetitive work while you focus on the hard decisions. This is actually a glimpse into the future of AI development. AI helping to train better AI, with humans guiding the overall process. Now let's talk about the architecture, because the way SAM3 is built internally is really clever. It's actually 3 separate systems working together. First, you have the vision encoder, which is basically the eyes of the system. It takes in images or video frames and extracts visual features at different scales. This is shared between the older two systems, so they are all looking at the same visual information. Then you have the detector, which is the brain. The detector is based on something called DETR, which stands for Detection Transformer, and it's specifically designed to find objects based on prompts. Now, here is what makes the detector special. It can accept 3 different types of input at the same time. You can give it text prompts like yellow school bus, you can give it geometric prompts like clicking on a point or drawing a box, or you can give it image exemplars, which means showing it an example image of what you are looking for. And here is the really cool part. You can combine all 3. You could say red car point to a specific area of the image and show it a reference photo of a Ferrari, and it will specifically find red Ferraris in that area. That level of control is insane. The detector also has something new called presence token, and this is SAM-Tree's secret weapon for handling subtle differences. Let me explain why this matters. Imagine you have a soccer game and you want to segment player in white jersey versus player in red jersey. These prompts are super simple. Just one word is different. All models would get confused because the text embeddings are so close together. The presence token creates distinct representations for each prompt, so SAM-Tree can perfectly discriminate between them even when they are very similar. Finally, you have the tracker, which is the third component. The tracker is actually inherited from SAM-2, which already worked really well, so they kept it. The tracker's job is to follow objects frame by frame through a video. It handles all the hard stuff, like when an object goes beyond something else and comes back, or when the camera moves, or when lighting changes. It maintains the identity of each object throughout the entire video. The key insight here is that Meta separated the detector and tracker into 2 specialized systems. Why? Because detecting and tracking are actually different skills. Trying to make one model do both creates what's called task interference, where the model gets confused about what it's supposed to be doing. By separating them, each one can be really good at its specific job, and together they work perfectly. Alright, now let me show you how you can actually get your hands on SAM-Tree and start using it today. There are basically 2 paths here, depending on whether you just want to try it out and use it, or whether you are a developer who wants to integrate it into your own applications. For most people, the easiest way is through the Segment Anything playground. You just go to segmentanything.com, no account required, completely free, and you can start using it immediately. When you get there, you will see 3 options. There is SAM-Tree, which is what we have been talking about, text and visual prompts for image and videos, and there is SAM-3D, which is for reconstructing 3D objects from single images. Each one has its own use cases. Let me walk you through the basic workflow for SAM-Tree. First, you upload an image or a video. The interface accepts pretty much any common format like JPGs, PNGs, MP4s, whatever. Once your media is loaded, you have 2 main options. You can type a text font in the box, something like person or red car or dog wearing a hat, whatever you are trying to segment. Or you can click on the points in the image, just like the old SAM models worked. Type your prompt, hit enter, and within a couple of seconds, you will see the results. Every object matching your description gets highlighted with a colored mask. If it's a video, you will see the mask tracking through all the frames. Now, here is something really cool. The playground has pre-built templates for common tasks. There is a pixelated template that automatically blurs faces, license plates, and screens, perfect for privacy. There is a spotlight effect that highlights specific objects while dimming everything else. There is a motion trace template that creates those cool trailing effects behind moving objects, all kinds of stuff. These templates are great for 2 reasons. First, they give you immediate practical tools you can use right now. Second, they teach you what SAM-Tree can do. You can see the prompts they are using, how they are structured, and learn from that for your own custom prompts. Once you have segmented your objects, you can download the results. You can download just the masks as images, which you can then import into other software like Premiere or After Effects. Or you can download the fully edited video with your effects applied. The whole process from upload to download can be done in under 5 minutes for most tasks. Now, if you are a developer or you are a more technically inclined and you want to run SAM-Tree on your own computer or integrate it into your own projects, it's fully open source. You go to GitHub, search for Facebook/SAM-Tree, and you will find the official repository. The model weights are hosted on Hugging Face, which is a popular platform for sharing AI models. You do need to request access, but it's free and they approve requests pretty quickly. Once you are authenticated, you can download the models. The setup is pretty straightforward if your comfortable with Python, you need Python 3.12 or higher, PyTorch 2.7 or higher, and a CUDA compatible GPU. For the GPU, something like an RTX 4090 or A100 or an H200 works great. If you have a decent gaming PC with a modern NVIDIA card, you can probably run it, though performance will vary. The GitHub repo has detailed installation instructions, but basically, you create a Conda environment, install PyTorch with CUDA support, clone the repo, and install the package. The whole setup takes maybe 10 to 15 minutes if you're following along. Once it's installed, using SAM3 in your code is actually really simple. Let me give you the basic pattern. You import the model builder, build the model, create a processor, load your image, and set the text font. It's literally 5 lines of code to get a basic segmentation. The repo includes a bunch of example Detector notebooks that walk you through different use cases. There is one for image segmentation, one for video, one for batched inference if you are processing lots of images at once, and one for using SAM3 as part of a large AI agent system. My recommendation is to start with the image predictor example notebook. Just copy it, change the prompts to your own test cases, and experiment. That's the best way to learn. For developers who want to use this in production applications, there is a partnership with RoboFlow, which is a popular computer vision platform. RoboFlow lets you annotate your own custom training data and fine-tune SAM3 for your specific use case. So if you are building an app for say retail inventory management, you could fine-tune SAM3 specifically on retail products. This gives you ever better accuracy for your domain. Looking ahead, Meta is integrating SAM3 into more of their products. It's coming to the Meta AI app. It's being built into Instagram edits with new effects. The marketplace AI features are rolling out. For developers, there is likely going to be official API access at some point, which would make it even easier to integrate into web and mobile apps without needing to run the models yourself. Now, let's talk about limitations, because understanding where SAM3 falls short is just as important as knowing what it can do. I believe in being honest about technology, and no AI model is perfect. SAM3 has specific areas where it struggles, and knowing these will help you set realistic expectations and use it more effectively. The first limitation is complex spatial reasoning. If you keep SAM3 a prompt like the second book from the left on the top shelf, it's probably going to struggle. The reason is that this requires counting, ordering, and understanding relative positions in a very specific way. SAM3 understands concepts and objects, but it's not doing the kind of step-by-step logical reasoning that this type of query requires. It can find books, it can find the shelves, it can even understand top shelf, but that second from the left part is beyond its current capabilities. If you need this level of specificity, you would be better off using a combination of SAM3 with a multimodal large language model like GPT-4 Vision or Llama Vision. The LLM can interpret your complex query, break it down into simpler steps, and then generate the right prompts for SAM3. The second limitation is highly specialized domain terminology. We talked about this earlier with medical imaging, but it applies to any specialized field. If you are working with specialized equipment in aerospace engineering and you need to segment a hydraulic accumulator valve, SAM3 might not know what that is if it wasn't well presented in the training data. For specialized professional applications, you might need domain-specific models that were trained on data from your field. The good news is that because SAM3 is open source, it can be fine-tuned on specialized data, which is what companies are doing for their specific industries. The third limitation is extreme ambiguity. If you have an image with 50 different red objects, and you just type the red thing, SAM3 is going to find all of them because it doesn't know which specific one you mean. This isn't really SAM3's fault, it's just an ambiguous prompt. The solution is to be more specific. Instead of the red thing, say red car or red stop sign or whatever you actually mean. The more context you provide, the better the results. Now, here is an important point. For 90% of real-world use cases, these limitations don't actually matter because you are not editing medical journals or aerospace manuals. You are editing YouTube videos, processing product photos, creating social media content, working on creative projects. For these normal everyday tasks, SAM3 works incredibly well. It's important to know the limitations, but don't let them scare you away from using it for what it's great at. Alright, so we have covered a lot of ground here. So here is what I want you to do next. First, go try it yourself. Head over to segmentanything.com. Right now, upload an image, type a prompt, and see the magic happen. It takes 5 minutes and it's completely free. I guarantee you will be impressed. Second, if you found this video valuable, hit that subscribe button because I'm breaking down major AI releases like this every day. We're living through the most exciting time in technology history, and I want to make sure you understand what's happening and how to use it. Third, drop a comment below and tell me what you would use SAM 3 for. What's your use case? What problem could this solve for you? I read every comment and I'm genuinely curious what creative applications you all come up with. The best idea gets featured in my next video. And finally, if you know someone who needs to see this, share it with them. If you have a friend who is a video editor spending hours on manual masking, show them this. If you know a business owner who is spending thousands on product photo editing, share this video. This technology is too important to keep to yourself.